Okay, so the next one would be how can we deal, okay, or how can we figure out the partial derivative of a composite function. Okay, so it will be similar as what we practice in a normal differentiation. Okay, we're going to use chain rule. Okay, so let me recap back on what means by composite function. So we know that whenever we are dealing with multi-variable function, okay, so now we as a simple analogy, if we have a function with two independent variables, so it becomes a composite function, okay, whenever the independent variables, okay, is a function of a single variables, for example t, okay, so that make the given function as a composite function. Okay, so how can we calculate the derivative respect to the t? Okay, so we're going to use this theorem. Okay, so technically you don't have to memorize this theorem. Okay, so if we know, okay, so we know that, okay, there is a function of x that depends on x and y. Okay, so meanwhile, okay, so we know that x is a function of t and y also a function of t. Okay, so if we would like to sketch the tree or the chain for the given function would be like this. Okay, z is depend on x and y, while x and y is depend on t. Okay, so from here, okay, if you compare this change, okay, so you will definitely get this formula, I would say. So we are looking for dz dt, okay, so it's equal to, okay, so if we take this chain, okay, so we're gonna have del z over del x multiply with dx over dt plus, okay, del z over del y multiply with dy dt. Okay, so if you see here, okay, so we have a different symbols over here. Okay, so you should know already, okay, the notation. Okay, so why we use curl when we write this part and this part? Because z is a function of two independent variable. Okay, why we use d over here? Since x and y only depends on t, means that is depend on one single variable. Okay, so whenever we change the given function, okay, so it might also change in terms of the formula over here. Okay, so let's take a look on first example. Okay, so we have z equal to x power of 3 y, okay, and then x is equal to ln 2t, while y is equal to t squared cos t. Okay, so the chain will be the same as what we practiced just now. Okay, so z is depends on x and y. Okay, so if we take a look on these two, okay, so x only depend on t and y also depend on t. Okay, so based on this one, let's figure out del z over del x. So you're gonna get 3x squared y, while del z del y, you're gonna get 3x squared. Okay, so now next thing that you need to figure out is dx over dt. Okay, so dx over dt, so you're gonna get 1 over t over here, while dy over dt, you're gonna get from this one, okay, if you're applying product rules, obviously. Okay, so you're gonna get negative t squared sine t plus 2t cos t. Okay, so we have all the terms that we need. Okay, so the answers that we are looking for here is dz dt is equal to, okay, so let me write straight away the answers over here. Okay, so dz dx is 3x squared y multiply with dx dt 1 over t plus, okay, is 3x squared multiply with all the terms of dy dt, negative t squared sine t plus 2t cos t. Okay, so since the question asks you to find dz over dt, okay, so normally, okay, these terms that involved with x and y over here, we're going to replace with the term of this one. So that the final answer will be in terms of t. Okay, so I think the space is not enough. Okay, so if you substitute, okay, so you will definitely get that the final answer would be 3 ln 2t squared cos t over t plus, okay, ln 2t to the power of 3 multiply with 2t cos t minus with t squared sin t. Okay, so if the question asks you to simplify, so it's compulsory for you to simplify. If not, you just substitute and leave it like that to ensure that you will not do any mistake whenever you simplify the terms, because the term can be long to write normally when we are dealing with chain rule. Okay, so the next example. Okay, so the next example, okay, I will just share the chain for this question. Okay, but I would say that is similar to what we practice in example 6. Okay, it's just that now we have a function of w that depends on 3 independent variable, while that 3 independent variable depends only on t. Okay, so if for example 7 over here, if we get the chain, okay, so we're gonna definitely get like this. Okay, so w depends on x, y, and z, and with this term, so we know that it definitely depends on t for all 3 independent variables. Okay, it's just that you have one more term to add or to figure out. Okay, instead of like this, so means that you're gonna have one more term over here that you need to figure out to get dw dt over here. Okay, so if you be able to solve for this one, so the final answer for this question would be 9t to the power of 8. Okay, so you can try by your own to solve for this one. Okay, so based on this example, okay, so I would say that is a simple analogy of chain rule question. Okay, but how can we deal, okay, if we have an arbitrary function like this? Okay, so I will show you, okay, whenever we have this kind of arbitrary function, how can we solve it? Okay, so let's take a look on number 2 over here. Okay, so z is a function of, okay, so inside is kx squared minus ky squared, okay, while k is a constant. Okay, so the question asks you, okay, so whenever we give you an arbitrary function, normally we ask student to prove the given equation normally. Okay, so the question asks you to prove that, okay, y del z del x plus x del z del y is equal to 0. Okay, so based on this one, okay, so you need to figure out this part and this part, the partial derivative, before you can actually show that from left hand side you're gonna get 0. Okay, so that's how you prove. Okay, so from here, we have, okay, z a function of this one. Okay, so if we would like to differentiate respect to x, okay, so over here, if we differentiate respect to x, okay, so you're gonna get f prime, and the term inside remain, right, because we differentiate this f respect to x. Okay, and the next one would be the terms that we differentiate inside, so you're gonna get 2kx. Okay, so same goes to if we differentiate respect to y. Okay, so now since if a function that depends on x and y, so if we differentiate respect to y, so you're going to get f prime as well, kx squared minus ky squared. So now the term inside, we're going to differentiate respect to y, so we're going to get negative 2ky over here. Okay, so from here, we're going to prove from left hand side is equal to y del z del x plus x del z del y. Okay, so from here we got y multiply with this part, f prime kx squared ky squared multiply with 2kx plus with x over here coming from this part, f prime, sorry, kx squared minus ky squared multiply with negative 2ky. Okay, so you will definitely get 0 for this one because you have minus on this side. Okay, so for arbitrary function, normally, okay, so normally the mistake that student always did whenever you are dealing with dz dx and dz dy over here, del z over del x and del z over del y over here. So whenever you are dealing with arbitrary function, be careful whenever you solve for this part before you can prove it. Okay, so I have provide 2 more exercise over here that you can try by your own. Okay, so yeah, before I forgot just now. Okay, so from example 6 and 7 that I discussed, okay, at the beginning of the video, okay, the independent variables, okay, is only depends on one single variable, but it also can depends on more than one. Okay, like this, if we have like this. Okay, so the terms will be a little bit longer. Okay. It's just that the notation also different because of now u is depends on 2, so that's why instead of we use d, we change to delta. Okay, but it depends on how you interpret, okay, the information given in the question, so that you will not be trouble in writing the formula before you solve for the question. Okay, so we have this kind of chain rule as well. Okay, much more longer compared to the previous one that you can take a look. Okay, but the idea is if you understand, okay, the original concept of chain rule, it shouldn't be a problem. Okay, no matter how many independent variables that we have in the given function. Okay, thank you.